So our last example showed how we can solve a system of equations using reduced row echelon form. That is called Gaussian elimination. And then we had Wilhelm Jordan come along, and he suggested to Carl Friedrich Gauss that, hey, let's do reduced row echelon form, and then extrapolating our solutions will be that much more simple. Okay? That is called Gauss-Jordan reduction when you do your, elementary row operations to get your matrices in reduced row echelon form. Reduced row echelon form has the zeros up top here as well. Okay? So you can imagine that once you get them in that form, you can just read what your system says. Okay, if this is like a 7 and this is a 4 after you do it, your solutions are going to be x is equal to 7, y is equal to 4. Okay, I'm just saying like if. Okay, and then down this column, like let's say that you had a -3, a 0, and a 2. Once you got that in reduced row echelon form, then the Gauss-Jordan reduction would say, hey, my solution for x is -3, y is 0, and z is 2. It's easy to read that. You don't have to do any back substitution. Let's see an example of how to solve a system using Gauss-Jordan elimination. All right, we kind of got a hot mess right here for number 46. We are definitely going to have to do a little bit of algebra to clean up these equations and write them in standard form before we even think about putting them in the augmented matrix. Okay, so first of all, I'm going to run the 2 through here, and I'll have 2x minus 2y equals 4x plus y minus 40. Okay? So let's say I want to subtract 4x from both sides and subtract y from both sides. My equations will look like -2x minus 3y equals -40. So either now or later when you put it into the matrix form, I'd really rather that probably say, multiply everything through by a -1. You can always do that. Not only, we've been able to do that forever, okay? Not only just like multiply row 1 by -1 to get a new row 1. Okay, let's do it here. So that is equivalent to 2x plus 3y equals 40. All righty. Now, on this next equation, I'm going to add 3x to both sides of my equation. And so that's going to give me 3x plus 9y equals 105. You know what I'm noticing? Okay? Everything there is divisible by 3. Now with our elementary row operations, we would be saying, okay, take a -1/3 times row 2 to get a new row 2. Okay, y'all, what that means is divide everything through by 3, and we will have x plus 3y equals 105 divided by 3 is 35, I think. I hope that's right. Yeah, I'm pretty sure. Okay, so you can go ahead and simplify some of your equations here. Write them nicely before you put that into the matrix form. And in fact, since this has a 1, I'm going to write this equation first when I set up my augmented matrix to kind of get this party started. I'm actually going to write 1, 3, 35 first because I want that leading 1 right there. That's very important. 1, 3 augmented with 35. And then my second equation, 2, 3, 40 would be the entries that would correspond to that equation here. Okay? So we've got our matrix set up, our augmented matrix set up. We're ready to do some elementary row operations. It says use Gauss-Jordan elimination And so that means we're not only going to row echelon form, we're going to reduced row echelon form. We're getting zeros as much as we can in entries that are not on the main diagonal. All right, so first of all, I've got, and I already did a little bit of finagling so that I've got my leading one, my pivot number, okay? And so what I really ultimately want, here's my goal. I want this to be a 0. And so the way to make that happen is to get opposite coefficients. I'm going to be able to obtain opposite coefficients if I take a -2 times row 1. Then I'm going to need to add that to row 2 to get a new row 2. And the whole reason I'm doing that is so that ultimately I'll have a 0 sitting right there. Because that's beautiful when that happens. Okay, so here we go. Back to our task at hand. Taking -2 times row 1. That would be a -2. -2 times 3 is -6, augmented with the -2 times 35 is a -70. Okay? Row 2, y'all, that was 2, 3, 40. And now when we add those together, our new row 2 is going to have the -2 plus 2 is 0. A woohoo! That's why we did that. -6 plus 3 is a -3, and -70 and 40 combine to give us -30. Let's write our new matrix. Row 1 doesn't change, y'all. It's still 1, 3, 35. Even though we used it here to get -2 times row 1. Okay, that's not our new row 1. We only got a new row 2 of 0, -3, -30. All right, what do we want now? What we want now is a 1 right here on my main diagonal, okay? That's what we want to happen. We want that 1 there. And so we can easily accomplish that if we divide everything through by a -3, right? Okay, so technically they say what you're really supposed to do is instead of dividing by 3, you're supposed to multiply by -1/3. That's the same stinking thing as dividing everything through by -3 is multiplying by -1/3. So I'm going to take -1/3 times row 2 and get a new row 2. Okay? That's actually how we show the world and track what we did. Yeah, but really what I'm doing is I'm dividing everything through by a -3. And that's going to give me my new row 2. Row 1 is still 1, 3, augmented with the 35. Now my new row 2 is 0. Okay, now don't forget we also divide this by -3. Well, 0 divided by -3 is still just 0. Okay, here's where it's interesting. -3 divided by -3 is a +1. And then -30 divided by -3 is actually a +10, not a -10. It's a +10, isn't it? Okay? All right. Okay, now I know it's tempting right here and say, oh, I know y is 10, and I could just do a little bit of back substitution to get x, but we're following our directions that said our next goal to get this in reduced row echelon form so we can use Gauss-Jordan reduction, okay, because Gauss and Jordan are like, hey, Jordan's like, hey, don't forget me. Okay, that says that you want a 0 here as well. That's our goal, is to get a 0 there. Now, that could happen if this number turned into a -3. You might be going, well, why'd you just divide by -3 if you want that to be -3? Well, okay, don't give me a tough time. Okay, what we're going to do to make that happen is we're going to get the 0 up there, to get the 0 up here where we want it, okay, we are going to take -3 times row 2, right, added to row 1 to get a new row 1. that's going to have a 0 where we want it to be. Okay? See how this works. -3 times row 2 is -3 times 0 is 0. -3 times 1 is -3. Augmented with -3 times 10 is -30. If we add that to row 1, which is a 1, 3, 35, okay, we're going to get a new row 1 of 0 plus 1 is 1. -3 plus 3 is 0. We wanted that 0 there. That was our goal. And then -30 and 35 is +5. Okay? So now our augmented matrix with our new row 1 is 1, 0, augmented with 5. I got that from right here. 1, 0, 5. And then our row 2 from right here doesn't change. It's still 0, 1, 10. Now don't forget, this is your value for x. This is your y. And so this equation is equivalent to x equals 5. The second equation is 0x plus 1y equals 10, y'all, or just y is equal to 10. There's your solutions to that system of equations using the Gauss-Jordan reduction. Again, they'd probably want you to express that as an ordered pair, but there it is. Okay?